Okay, so let's look at the exercises in this. The first of which was the proof where we had to prove that segments DB and EC were congruent to each other, and these are these two here. And so the first reason that you had to supply was for step 7, which said that the two triangles are congruent, ADC and AEB, and that came because we got that we have two right angles here, which right angles are congruent, and so we got that ADC and AEB are congruent. We got that angle A is congruent to itself, and then we also got, or I'm sorry, these angles right here, and then we also got that side AD is congruent to AE, so by angle side angle, we got these two triangles congruent, and we got an angle in step 3, we got an angle in step 5, and we got the two sides congruent, AD and AE, in step 6. Okay, once we had these triangles congruent, now we can say that AB, this long side here, and AC are congruent, and that would be by CP, CTC, because those are congruent parts, those are corresponding parts of congruent triangles, and they're congruent. Okay, so then once we have the longer segments congruent, and we already knew that AB and we already knew that AD and AE were congruent, that left from D to B being congruent from E to C, and that would be by the subtraction property. Okay, so again, what will frequently be happening is we will use triangle congruence proofs as part of proving something else, and then we'll use CP/CTC. Okay, so the next thing we had to do on the next page was we had to prove that, and let me just erase all this, we had to prove that these smaller triangles, we'll call this F, so DFB and EFC were congruent. All right, so we already have that these are right angles, the same reason that we have up here in steps 2 and 3, and that is that these are altitudes. We also have, because we got that those two triangles, ADC and ABC, or an ABE were congruent, we got these two angles here congruent, and that we would just say by CP/CTC. And then finally, we got that DB and EC were congruent, and really that's a given because we proved that, and that means that by angle side angle, then we got that those two smaller triangles are congruent. So we ended up here with angle side angle congruence. Okay. For our next exercise here, you were asked to supply the reasons here. So we have that we want to find the reason for why SVZ is supplement of TVZ. So we have this angle here, and then we have this angle here, and the question is why they're supplements. And the reason for that is that supplements or linear pairs form supplements. You do not need to prove that they're linear pairs. You just need to assume that from the diagram. And we don't want to say definition of supplements here because we need to refer specifically to the fact that these two are linear pairs. And then we use the same reason in step 4. Step 5, we say that TVZ and YXZ are congruent. And the reason for that is that supplements of congruent angles are congruent. Okay, and then in step 7, we had that TVZ and YXZ are congruent. And we got that because we already had these two angles congruent, and we got that these angles up here were congruent to each other, and then we also had that TV and YX were congruent, and so therefore we have that these two triangles, and the reason for that would be ASA, and the steps there. So we got one of the angles in 1, we got one of the angles in 5, and then we got the two segments congruent in 6. So those were our steps. And then 8, now we can say that TZ and YZ are congruent, and the reason would be CP, CTC. Congruent, corresponding parts of congruent triangles are congruent. And then for 9, now we can say that SZ is a median, and we can say the reason is if ray cuts segment into two congruent parts, it is a bisector. And again, because we're dealing with a definition, this if-then statement also works in reverse. If it is a bisector, a ray cuts segment into two congruent parts. And again, that does not work with most theorems, but it does work with definitions, that you can reverse the if and the then part of the statement. Okay, moving right along here, our congruent, we got to the HL postulate, which says that in two right triangles, if we know that we have two congruent, the hypotenuse is congruent, and one leg is congruent to a leg in the other, then those two triangles are congruent. Even though technically we have SSA. In this case, we can use that, but we call it HL. It's a postulate, hypotenuse leg, and it only applies to right triangles. Okay, so now we're going to use that, and we're going to use it to prove that ACF is isosceles. And so what we're going to do here is we're going to first say, we'll introduce some givens. We'll say that BD is congruent to CF, and we'll say that GE is, perpendicular to CF, and this will be given. And if I have two things of the same category, I can introduce them in the same given statement. And then we also have that CE, segment CE is congruent to segment DF, and that's again a given. And we have that BC is congruent to GF. Again, that's a given. Okay, so we have that these are right angles here. We have that CE and DF are congruent. And so we know immediately that therefore CD is congruent to EF. And the reason for that would be subtraction property. Okay, then we also have that BC and GF are congruent, and that was a given. So now we actually have that triangle, or actually we need to say that angle BDC is right angle, and that would be perpendicular lines form right angles. And 6, we would say that angle GEF is also right angle, and this would be same as 5. So now we can say that triangle BDC is congruent to triangle GEF. And we would go back and get the steps. So we have the H we got from step 3. We got the L from 4. And then we got the fact that it's a right triangle from 5 and 6. Okay, now we can say that angle C is congruent to angle F. And that would be for the reasons of CPCTC. And for 9, we can say that that AB or AC is congruent to segment AF. And the reason would be if opposite angles are congruent, then opposite sides are congruent. And 10 would be that ACF is isosceles, and the reason would be if opposite sides congruent, triangle is isosceles. Okay, and that wraps it up for this document.